Why not? Yeah.
You have to search for your dreams and live your dreams. That's what I'm doing right now, and never
Yeah, I
say
mean,
no.
what you are doing is great. I mean, have you you have worked on your own startup project and you made it successfully, you sold it, and now you are starting something else that also very
Yeah,
successful, I would say.
yeah. So I'm also interested in aeronautics, but not in the universe. A little deeper. I have a private pilot license.
Oh, that's really great.
But
Yeah,
I
but
can't reach the universe, so it's not possible with my pilot license.
I can imagine. Yeah, I find it's great. Okay, so let's get started about the topics we want to cover today. So
Hmm?
today it's like first introduction about relational database basics, just basics. Today I just give you like overview, database queries, how to write queries on one table, because like after that there we will make connections between tables, and we can also extract and do queries to get data from more than one table, so you can make like this relationships between two tables, three tables, and even more, and you can get data from these tables. The other topic we also want to cover conceptions and modeling of relational database, uh, creating relational databases, how to create relational databases, complex database queries on multiple tables, manipulating records in databases, not only SQL database system. These are the main topics we shall cover in this course. So for the unit
Hmm.
one, as I said, just covering relational database basics. So the main topics or goal from today to explain the most important relational database terms, describe how data in relational database is stored and read in a structural way, explain the meaning and the use of SQL. I hope also you can see now this laser. Compare among different commercial database management system. Okay, so first the question: how many times have you used database? I understood now. You already answered that. So like database is like a solution, because in the past we used like files, we stored our data into files, and we used like search to find data. And but if you have like complex system and like a lot of records, it would be very complicated. So even if you use something like access, Microsoft Access, it's still Microsoft Access is a solution from Microsoft to create your own database, and you save your data there. But it's still not that like the best solution for big enterprises. So enterprises started to like collect the data, so you can find like records. If you like, you can just imagine if you have a business, and in this business like you have many customers, and you have like if yeah, just imagine you are you're just a company for booking flights, so you have many customers. I would say like you have 1 million customers, so you have their names, their age, the like if they paid for the flight or not. So when any customer book flight in your website, you need to store the data about the flight, data about the customer name, age. So to organize all this information and more, we use something called relational database. Why it's called relational database? Because there are relation between the tables. So you create like database containing table for employees, table for customers, table for like booking, the booking of flights, for instance, many tables. So relational database, you make this connection between tables so you can store the data with like information in every table about about customers, about their trips, and so on. This is like one example. Why most of organizations now use relational database, and why it's useful for their work. It's organize their work. It makes to search and to find information about flights easier. Like you can imagine now when you just go to supermarket, like if they don't have this scanner, this scanner to scan the product barcode, and they like to detect and tell you the price, and collect all this information from one system. So at supermarket, they have a database. In this database they have all information. They store all information about the product, price, and barcode. So when you search for barcode, as when you search for a barcode and you want to just collect the sum of products, it will be easy task. But in the past, when we have had only small shops, they didn't need something like this, because like it was a small shop. For At every small shop, they just sell some products. The seller knows in his head, like he can remember this and that. Every product costs like this or like that, and then they can just collect the sum of these products when you and then you pay, and that's it. But now it's getting more and more and more complex. In this way, we use like solution based on database to store this kind of information. So I hope now it's more clear for you why do we need something like database, why we need like solution like this, why websites needs this like database to store, as I said, to store their data and use them. Nowadays, there are more and more applications based on database solutions, like analyzing data. Like I'm not sure if you heard of ChatGPT or not, but this kind of solutions, they are based on databases, storing data and working on data, getting collecting data and analyzing data and giving customer insights. After analyzing the data and giving the customer insights, you can just have forecast for the future. You can give your company forecast about, like, if like the last 5 years we sold like was every year was like $10 million, and you can know exactly when you have to have big inventory, because most of customers buying at that time. This is one example. Another example, you can use also stored data for production. Like if you like sell with that amount of money, and you get products from like suppliers, and you need to predict also the amount of products you should have at your inventory in the store, so you can sell and also have the products in time. This is also something very important. There are many applications you can think of when we talk about using data, and when you store data, how you can use the benefit. Nowadays, data became more and more important. So there are some companies now just to collect data and sell them by giving you access. There are other companies like provide solutions for tracking like locations. Something like Uber just have access to the exact location, and they store this information in live time, in real time, so you can check the closest driver near to you. So you can order using Uber app to find like the nearest one to you, so you can book him or her to drive you to your location. This is one service, and you can see this service just storing locations in real time. And this project, like you can imagine, it's very big one. Something like Facebook, they also storing data about you, like your photo, like your posts there. Instagram as well, storing photos about like profiles, and sharing also some images, video, small videos there. YouTube storing videos. So this kind of solutions are, as you can see, just based on storing data. So data could be in different formats. So how you work with this in different formats, this is something we will talk about also in coming lectures about like how to store also different formats of data, and how you can also use them. Why would we prefer to use DBMS? DBMS, it means database management system. This is a tool. This is a tool. We provide this tool to manage your database. It's easier to use. Why we prefer to use this? Because it makes the look like when you search for data easier. When you want to manipulate and edit and change in your data, it become easier and easier. So this is what we talked about, like like basic concept of relational database model. We store data in databases. Databases are optimized for processing large amounts of data. As I told you, like you can imagine how big this or how huge this database from something like YouTube. YouTube like have billions of videos. Like it's a really you can imagine how big their data center. Facebook as well, they're storing like every single possible information. Thanks, Trolla. Yeah. In the book, yeah, you have already the book. You can just go through. I mean, in our presentation, I just give you like a little bit info, and you need to do your like reading, read the book in details, and if there is anything in the book, and when you also uh, start to learn with yourself anything related to this, just write me here in chat if if there is anything not clear. I mean, in our lectures, I just give you, this is interactive learning. Interactive learning, I'm not the one who give you information. You also look for information. You try to read the book fully, and if there is something not clear, you can just come next time, or you can just try and ask about it, or you can just write in chat, and I can also help you answering these questions. Multiple users can access the data simultaneously, like something like YouTube. So many users can access the videos at the same time. This is also something based on storing data. Databases provide consistency rules, like how you make consistency between the data. Like if you make transaction, the amount of money you just transferred would be just removed from your account right away. How you if the bank has like many ATMs around Germany, when you do that here in Berlin, when in Munich, for example, I'm in Munich, so if you do it in Munich, if you check your account online in your app and on the mobile app, or you check another ATM at the same time, you will find these changes are done at this are done. So it means any changes happening on in this data will be impacted right away. Here I will just can you hear the voice? I mean, can okay, that's great. I mean, in this video, it's like introduction. Also, in every lecture, you will find this kind of videos also to give you overview about the topic. So let's watch this one.
Hello, my name is Shadi Aljit, and I'd like to introduce you to database modeling and database systems. Data is omnipresent in each and every aspect of our modern societies. We can hardly think of an activity, whether professional or everyday life, that does not involve data used in one way or another. It is well known that the current rate of data production and communication is unprecedented in human history. This is why, when data is not organized or structured, it might be overwhelming to make use of it. Databases are the means most frequently used today to store data in a structured and organized way. Not only are we interacting constantly with databases in our everyday lives on the individual level, but databases are extensively utilized on the global level. Healthcare systems, worldwide navigation systems, social media interactions, finance and economy, as well as weather prediction are just a few examples of the use of databases. This course covers the essentials of databases and database modeling that allow us to design, develop, and maintain efficient data and information management systems. In this course, we will have this opportunity to learn about databases. And in Unit 1, we will start with the basics of relational databases. Relational databases dominate the market for a few decades now and provide a compelling means for data processing. In Unit 2, we will take a look at database querying. This means that we want to extract specific data that we are interested in out of a much more considerable amount of data stored in the database. We will use SQL to query the database, and we will start by querying one table. Unit 3 covers the basics of database design and modeling, creating entity relational diagrams or ERDs, and we will learn about improving data integrity by normalizing the database tables in Unit 4. At this point, in Unit 5, we will be ready to look at the actual creation of the database, as well as more advanced queries that extract data from more than one table. In Unit 6, we will learn how to manipulate data in the database and look at one of the essential aspects of database processing, the transactions. Finally, in Unit 7, we will take a look at some advanced types of non-relational databases, namely the NoSQL systems. I hope you are as excited as I am working on this predominant topic, and with this, I wish you the most success in this course.
So, as you saw in the video, also there are many applications. As I said, there are many applications database are used in, like healthcare, finance, and many others. This is components here in the diagram, where, as you can see here. So the components of a database system: business application 1, business application 2. So you have database DBMS, that's a database management system, and you have the database. The DBMS, database management system, is connected to database, so you can work, manipulate, and get the data from your database. You can get the data, the data from the database, and you present this in application one, like one application to present specific data for customers, and business application too. You can also present other information about like your employees. It's not, it doesn't have anything, for example, to do with like application one, but it's coming from the database. Why do we need this DBMS in the middle here? Because it's getting the data from the database to present it. So it can retrieve data, it can manipulate, if you wanted to delete record, if you wanted to add record, and so on. Okay, you are saying something, Turlak. Can we go through from the book each topics, every topic, because we are responsible for all things in the book and it's difficult to understand. Yeah, because in the literature, I have to follow the presentation. I get this presentation from this not like something I add, or the presentation I get it directly from the website. I mean, from the university, from IU. IU sent me this, and I have to follow this presentation. So this is how I teach every course at IU. That's why I told you the here learning is interactive learning. So if you have any questions, you can just send me an email with your questions. Things not clear for you, I can send you like more material, so you can understand the topics better. But I have to follow anyway the presentations I got. That's why I can't use like the book instead of the presentation. Is it clear for you now? Tarek, is it clear? So, okay, so if you just have any questions after reading and so on, you can just collect these questions. I will give you like some examples. I can give you also some inputs, some explanations, and so on. But here I have to follow the presentations as I mentioned. Okay, so in relational database, how we build the database. We build the database using tables, and every table we have rows and columns. Columns just store, in columns we store a specific property of data. Like as you see here, this is a column. Like we say here is this column containing customer number, title, last name. So this column will be presented with this property, of data. Rows, in row, it contains data. It contains data about one entity. Like here, this customer number 20, his title, last name, email, and so on. So you can imagine how now better how we build every table in the database. We have the table name. This table name is customer. Columns in this table are attributes. Every column is representing attribute, and columns just contain data about one entity. This also another video about.
Welcome to the introduction of Unit 1. This unit aims to introduce you to the basics of data structuring and storing in databases, database management systems known as DBMSs, and then we will introduce SQL. Naturally, humans tend to exchange information unstructured. For example, think of a human speech, reports, letters, and photos. However, when data is to be processed, a more structured organization would be preferred. Computers need the data to be structured to be able to process it. One of the most frequent ways data is structured for processing in computers is tables used in a relational database context. Simply, in a relational database, data is stored in tables with relationships among them. The data and the tables of a database will be often physically stored on hard drives. In this figure, you can see the database as part of the database system. In order for the users to be able to interact with the database, there should be some kind of interface that provides different functionality to the user. It is through the database management system, or the DBMS, that users can create, process, and administer the database. Users usually see only the application interfaces and use them to send their requests to the database. The DBMS translates these requests into the actions that can be carried out on the database. While users might only interact with a graphical interface on the application level, behind these interfaces, the actions on the database should have the form of commands that use a language that the computer or the server can understand. In today's database market, SQL is the most frequently used language. SQL stands for Structured Query Language, and it is a data language, which means that it is a language used only to process data. We can divide SQL commands into different sublanguages. These are DDL, Data Definition Language; DML, Data Manipulation Language; DCL, Data Control Language; and TCL, Transaction Control Language.
As you can see here, relationships in relational databases between the data, as I told you before, like there is a customer, and every customer has like primary residence, like location, and in this we have something called one-to-one. So we have also between customer and home relationship, and this is called one-to-one. So we have to understand this better, we have three different relationships. First relationship is called one-to-one, like this. Like every customer like has one primary residence. When you ship product, when the customer orders something, he can't give you like one address, second and third address. It's just one address. You can ship the product to this address. In this case, we call this relationship. When we store this data, we call this one-to-one relationship. But customer has like can have like other addresses, like here in this case it's like Amazon can ask you like if you have one and the second and third, but when you wanted to select, you can choose between these addresses. In this case it's called one to many. One to many, you can say like one professor and many students at the same time. In this case it's one to many. Like this is the relation called one to many. There is another relationship called many to many. In this case, uh, about the primary key and the foreign key is every table. Yes, I will still explain. I will still explain how to decide the primary key and the foreign key. I understand. Yeah. I still I'm still just talking now about the relationships, and then I will go through the primary key. Okay, the relationship here called many to many. This breaks the relationship into two, like one to many relationship using a relationship table. What does it mean? It means like you have billing address, as you see here, like many billing address to many customers. I will give you another example. You can say everyone has many books, for example. Like every student has many books, and every and like every book can be also can be also read by many students. Like it's one book in the library, and this book can be read by many students. In this case, the same book can be read by many students, and every students can read more than one book at library. In this relationship, we call it many to many. Why it's many to many? Because every book can be read by many students, and every students can read more than one book. So in this case, it's called many to many. Back to your question, Torlak. So how we define or to decide about the primary key? Like I will go back here to the this one. Like if you have a table like this, you need to define which column here. You have 1, 2, 3, 4, 5 column. You need to define the column which is unique, and you can use to define, like if you say, okay, what like you can have like many many customers with the same last name, right? Right. You can have many customers with the same last name. You can have also many customers with the same first name. The title, also you can have many customers with the title. So to select the primary key in this table, we need to define one column which can distinguish or be unique to define the whole row. So in different records, like you have 1, 2, 3, like thousands of records. So if we give like uh, every customer number, and this number is every time different, in this case we will select customer number as primary key. This is the primary key. It's like one the one that distinguish the table, and it's like unique. So you can define, if I ask you like what's your ID for exam, like you use this ID, I can use it as a unique, so it's primary key for your student identity. The same for the identity for with your ID. Like in your ID, there is number, identification number. This ID is unique. Then we can use it as primary key. Okay. So what is again? Yeah, there is something called composite key. So you can, if the number of, if in the table the column not unique, so you will use like two columns together, then you can so in this case this composite key will not be repeated. So it, but in this case the customer number is not repeated, so we can select this one um, as primary key. But just imagine another table, and that table we don't have like a unique number. So in this case it's not easy to define the primary key. In that case we need to define like two columns together. So in this case you have this two columns together or composite key as your unique primary. Or you can introduce technical case that is unique for sure. Yes, you can add ID. You can add ID. It's even better and easier for you. I mean, it's your decision. When you build your own database, it's your decision. You have to think about it, like, okay, I wanted to organize my data or my table in this or that way. But what if you just join a company and they have already the tables? So if you can't change, you should understand this, like the differences between between foreign key, composite key, primary key, and so on. Like I can add to the table a contact table and add contact ID and include emails. Add contact ID and include emails. Like yes, you can do that. I mean, it depends on you. How it's your decision. Brand, not by default. You can when you create a table, you can or create like one column specific for that. It's your decision. When you create a new table, it's your decision. So you can make even the name. You can make the name as your primary key if the name is not like, or like a mix between first name and the last name. In this case, you have now the primary key mix, or like a mix between your first name and the last name. It's your decision. It's not like the database will do that automatically or not. It's your decision. You can also add like you can imagine if you have table for like billing. Every time when your customer order on your website, so you can use the timestamp from the order as unique. It's your decision. You can add the specific order ID. So you can add something called order ID, and this column will be your unique or primary key. So it's your decision, as I said. So okay, so if we wanted to also talk about the foreign key, the foreign key is the primary key in a table, which is not which is in another table, which is not primary key in another table. Like here, customer number. If you use this in another table, that table called like orders, and this order containing like order ID, customer ID. And in this case you have the customer number, which is here in our case here primary key. In the other table would be foreign key. It's called foreign key. Like the foreign key, the definition of the foreign key is so easy. Foreign key is primary key in another table. Like I have this column, the same column in another table. In this case we call it foreign key. Okay, so as insert the primary key of any tables, and the foreign keys. Yes, exactly. Here it's not describing that well, but as I told, like in the other table, if you have like one column, this column is primary key in another table, we call it foreign key, because we make the relationships between the tables through this foreign key. When you select data from table, you can select the related entries or related records based on this column, the foreign key. I can add this is your question, Torlak, here in chat. I can add customer table ID to the contact table like foreign key. Yes, you can do that. Like you can add like in the contact table containing like contact number. So you can in this case you can add like the contact number as a primary key, and the customer ID as foreign key. Or as I told you, you can have like I will write it in chat. Like you have table called order. Okay, table, you have like order ID. This is the primary key here. This is the primary key. And called the second column called customer ID. And in this case, we call this one as foreign key. Please check chat. I added the description chat. Like you have now table called order, and you have the primary key in this table, order ID. And you have the second column called customer ID, the customer who ordered this order. And in this case, this is the foreign key. Don't mix between relationships between tables and the column which called primary key and the foreign key. Okay, don't mix now. I mean, I want that you understand primary key and the foreign key as a concept, and then the relationship, as I told you, like a relationship is too easy. Like if you if the like I will give you another example for relationships, it will be easier for you. Like in the department, if we say every department has only one manager, in this case, what do you say? What is the relation between manager and the department? One to one, exactly. One to one. No, it's so you can manage only one. You can manage only one department. Okay. What the relation between the same employee, this manager, and the company? So company has many employees. The company has many employees, and the manager is employee. What is the relation between the company and that employee? The co- the company has many employees, exactly one to many. So the company has many employees. Okay, what is the relation between, like, if you have one, in this case, if you have like many companies, like many companies and employees in the same like city, like so the company has many employees, and this employee and you and every employee can work like for like two jobs or more than jobs, or more than one job, like, or I will give you a better example, like the relation between subjects at school. Okay, subjects and students, like this, in chat, subjects and students. Every student has more than one subject, right? And every subject has more than one student. In this case, we call it many to many. Exactly, exactly. So don't mix, okay? Don't mix the full picture between the relation between these tables and the concept of the column itself. The column itself, it's distinguishing the table. This is called the primary key, the primary key in another table called the foreign key. Okay, okay, thank you. So relationship, or this is like the mathematical model for the relations. It's called Cartesian product. Why we call this Cartesian product? Because when you try to collect every record in this table, you will do the Cartesian product, like a1 with just multiplied by a2 till you reach a of n. So when you do this relationship between like one column, like I will explain it in better way. Like if you wanted to bring from a table all the orders from one customer, like you have a customer ordered 10 times different orders. So if you are searching for all the orders from the same customer, you will select all the orders from the customer with ID, like I would say number one. So you will go through the table and find all the orders where the customer ID was one. In this case, we call that Cartesian product because you collect every time that person ordered then you collect all orders with the same customer. So that's why we call that Cartesian product. A table is an illustration of a relation. As I said, it's just collecting or data, and this can be related to another table, as we talked now about the customer and order. So this is illustration of relation between other tables. Data record. All data in a table row are referred to as a data record. So every row is record. Every row in your table is record. Entity is something, like it can be like employee, it can be a company, it can be like, so it can be so something separate and distinct that can be uniquely identified among the other similar entities. Like we call every table entity. We call every table entity, which is something, or it's something we can use to identify or distinguish something. As a student's table is entity, customer table is entity, address is entity. Attributes or property, its concrete properties of entities are described as attributes. Like attributes, for every entity you have attributes, or we call them property. It's concrete properties. So this is our only properties of your entities. And the values inside this table are also entity. No, the values inside your table, it's like object from this entity. Like if I tell you like 39, okay, this is value inside your table or your entity. Like 39, this is like edge from someone in your table. This is not entity, this is like value inside record from entity. But the entity, it's like if I tell you like our entity, it means like it's something separate. I can like describe it as something I can use. I like differentiate with, like if I say department is entity, because this entity has some attributes. Every entity has like every entity has some attributes, and with these attributes we can distinguish between the other entities. So this is the structure video about structure
Structure of
relational database.
Relational databases are frequently used as a data processing model in today's market. Humans tend to exchange data unstructured. For example, here you can see an unstructured text that contains many parts of data. For example, the number of branches of the company, the name of the branch manager in London, her email address, and phone number, as well as other pieces of data. One way of structuring this data is to organize it in a table. A table is a data structure that organizes the data in records or rows and fields or columns. Notice that in order for the table to be used easily, there should be an identifier that is unique for each record. We call this identifier in the relational database context a primary key. The name relational databases come from the fact that this model is based on mathematical concepts known as relational algebra. In relational algebra, the data structure that stores the data must be a relation. And actually, this is why this model is known as the relational model or relational database. A relation is a table that has particular characteristics, such as rows contain data about instances, columns contain data about attributes. Data in cells is atomic, which means that it cannot be broken into smaller pieces of data. The order of columns is not important, and the order of rows is not important. Looking at this table, we can see that we have 3 countries with local representatives for London's branch, all in one cell. For this cell to be atomic, we need to split the row into 3 rows. And we get this table. Notice that in this table, we cannot use the branch main office location as a primary key because it is not unique. To solve this problem, we will, as we frequently do, add an artificial identifier that we call a surrogate key, which is the primary key also in this table. We will add it to the table to guarantee the uniqueness of the primary key.
So primary key, as we just described, it's just like identifier or particular record. Artificial key or segregate key, it's meaningless attribute. It's just added to a relation only to identify record and used according as a primary key. So we just add it for this purpose. Foreign key, it's an attribute of a table. Is called a foreign key if it's a reference a primary key on another table. So referential integrity ensuring that each value of a foreign key in a child table matches one or more primary key values in the parent table. Database management system, DBMS, is a software. As I told you, it's just software or a tool we use for operating database, and we call it just DBMS.
Relations among tables. Relations among tables are essential to maintain the data integrity in a database. One of the main benefits of relational databases is that they allow us to avoid data redundancy. Data redundancy means that portions of data are unusefully repeated. In this table, you can see that several rows contain the same data, such as the branch manager's name, the email address, and phone number. Redundant data is not a desired feature in databases. On one side, we are wasting storage space to store the same data repeatedly. On the other side, editing the data for one instance will require editing it for an undefined number of rows. We can solve the data redundancy problems by splitting the table into 2 tables as shown here. The table has been split into 2 tables. One contains only the branch's data and the other contains data about the countries with local representatives. However, even though these 2 tables do not suffer from data redundancy, they have another issue. We cannot understand the relationship between the 2 tables. To solve this issue, we need to insert one of the fields of the branches table, the one on the left, in the local representatives table, the one on the right. The field is the branch's main office location. And by this, we get what is known as a one-to-many relationship, which means that one branch is related to many representatives. There are two more relationship types. The first is the one-to-one relationship. In this relationship, each record in one table is related to exactly one record in the other table. Finally, we have the one-to-many relationship, which means that many records in one table are related to many records in another table. Here, for example, we can see that a representative covers several cities and a city can be covered by several representatives. DBMSs cannot directly process this kind of relationship, and accordingly, they should be broken into two one-to-many relationships as shown here, and this can be done by using what we call a relationship table that includes only the primary keys of each of the original tables.
So here, as you watch it in this video, it's like this, how we make these relationships. We will go through that in next lectures, but this is how we make these relationships. Sorry, you have here question, Torlak. Okay, what is the meaning of data in cells is atomic? Atomic data, it means the data can't be divided. What does it mean? Okay, what does it mean? It means like the data in each column, when you put the value, this value can't be like divided like a string or integer or this kind of data. It's when there is a change, it's will be done once. Like you can, as I told you before, I can't say, okay, I made like a transaction from my bank account, and this amount is not there. Okay, so in this case, I will just give you something. 1 second, I will give you just something about this very quick. It will make this easier for you to understand. I put it in chat. I hope you can see that now. This is the definition of the atomic value, and here a link with like some more information. But the idea of atomic value in the database, the main problem with transactions, just imagine if you have bank account and you can do the like this transaction, and it will be impacted like part of it now, but the same amount you can do it twice, like you can do the transaction twice. Or if you like send some money to someone from your account to another account, and these transactions can be like divided the transactions. So any transactions happening to the database, it should be done in total consistent or not done. So this is how the transactions, everything working. Otherwise, you can imagine that like one transaction would be done, or the value would be done like more than one time. So as you see here in this description, the atomic value is a value that can't be divided. For example, in the table here in this link, you can show like if you make like some like color. If the color is yellow, you can't have another like divide it, it's yellow or blue at the same time. This is not how you work with the value. So the value or the atomic value is like can't be subdivided or divided. Okay, here again to the presentation, finding and deleting records in the database. Like if you have one entity or record or table called account, and one called operation, one called client. The relationship between client and account, the client can has many accounts. In this we say one, too many, too many. This is many. And the relationship between account and operation is one to many. One account can has many operations. So when we want to define information about account and the operation happening on this account, in this case we use this connection between account ID here, which is primary key, and here account ID is foreign key inside operation. So account ID in this account is primary key. Account ID in operation table is foreign key. Through this connection, through this connection between these tables, I can find records about the all operations happened to this account, and I can find these records, or I can detect these records and delete them. We will learn how to delete them using SQL queries and SQL in the future. I mean, in the coming lectures. So this is like the table of client has account ID, client ID, balance, and so on. And here is the client has in client ID. Client ID here is the primary key. Here is primary key. Here is foreign key. When we make this connection between them, so we can just select all clients with like this account, and we can just show all of them. So if you see the data here, like client ID has an ID number, has first name, last name, and some information, operation. So how you connect this data with this records here in operation, you need to define the connection like operation ID. In operation, in operation, you have account ID, inside which is connected inside account. It's here. There is connection between this and this. Account ID here is foreign key, and it's in account here is primary key. Through this connection, I can just grab the data and retrieve them. Extracting data should be in the next lecture. Extracting data from different tables. So we talked a lot about something called SQL. I wanted to explain now. SQL, structured query language. What is structured? This is language we use to deal with databases. This is like language a database can understand. So we use SQL to do like manipulations, retrieving for the data. So and it should be written in like a specific way. You should know how to select, how to write select, how to write also manipulation. We have subcategories of SQL. So you can do manipulation. Manipulation means you make it. You manipulate your data. You can delete record. You can modify and change record and so on. This is like subcategory. There is category called data definition language. This is like just a definition or dictionary of definitions for in your database. Transactions transaction control language. This is everything related to transactions, how we control them. This is just language of transactions, and we will have also more and advanced information about transaction, because when we work on uh, any transactions between tables and how we do these transactions and so on, this is called TCL. And we have data control language. This is just about how you control the data. So the main idea here we have, or that you have to understand today, is SQL. SQL, this is language. We use this language to deal to deal with records in database, and we how we call and use these connections between the tables to retrieve and show data. I want also to today to talk to you about different uh, tools in the market which we can use for managing, controlling data, retrieving data. We have many solutions. MySQL, this is free. You can just download, and I will advise you to download it and start reading a little bit about it. Oracle, this is from Oracle company. Oracle is very famous one. There is also one from Microsoft called the Microsoft SQL Server. Maria database. This is also like one database, but MySQL is very famous. Oracle is one of the most one used in the market. So okay, so this is like a review. Yeah, okay. So like you have here one question. What is the difference? There is the IBM database, of course. There are still others, yes. But I mean, this is like just one example. I mean, as I told you, presentation doesn't give you like every possible thing about the book. It's just giving opening the topics. In presentation, we just opening the topics. Okay, so no. SQL is language. This is like language used in all. SQL is a standard. You use it in all different companies. You use it from the tool from IBM company. You use it from MySQL and so on. Okay, so what your question? But you extract data in SQL format from MySQL. Okay, and also you do the same in Oracle, and you do the same with Microsoft SQL Server. SQL is standard. SQL is a standard. Okay. What is the difference between data control and data manipulation? Okay, data manipulation, when you want to delete, update, like insert, this is called data manipulation language. Okay, this is the main topic. Okay, what is difference between data control? Data control, this is about the access. If you have access to do that or not. Like you can imagine if you are a user in a website and you wanted to delete some product from the website. W- the only access can give you this like admin if you have admin account. So you can't do that without having access. So data control, this meaning it managing the access, managing the access, or who has authorities to do that. So the definition of data control, as I told you, it's like a language. We use it for to control access of stored information in database. Is it clear now for you, Torlep? Okay, so manipulation, don't mix between them. Manipulation, to manipulate. Manipulate in English, it means edit. Uh, edit, to edit something, to like to make changes on something. But control, it means like if you have controller, controller doesn't change. Controller just to check. Controller just to check if you have a ticket or not. But it doesn't sell you a ticket. It just to check if you have or not. If you have a ticket, you can go to a concert. If you don't have, you can't go. Something like this. Yeah, it's like some controls, some access control. Yeah. Okay, so the review about today, and also what you have to understand, and also you need to read from the book. Please read the book in details. And if there is something not clear, you can write me in chat, and I can also provide you with some like tutorial which can help you to understand the topics in the book better. Okay. So this is our goals from today, which we covered. So before we close the day, you have a task. We You will work on it, and in next lecture you will represent what you have done. So please work on this task. This is a task for you, and in next time you will explain that. Okay. This one you will find it in the presentation. Okay, and you will present your results next time. What is the relationship that needs to be broken into more two relationships to be able to implement in database management system? Please write your answer in chat. Okay, I will answer your question. You have another question here, Tola. Business application access the data stored in database. Yeah, you don't give your customer business applications, like it means you don't. Do you delete photos from your account on Facebook or WhatsApp or Instagram using database management system? No, the company give you like interface or application. Here means the show that you see, the presentation, like you see it in like in Facebook app. So Facebook, it's like application. You open it. This is the application. So you can delete your records. You can edit through this application. You don't give your customer like the database management solution. This is something advanced. This is for programmer. This is not for customers. That's why we provide customers with something like they can understand. So we give them like application. Through this application, they can do this work with the data stored in the database. Is it clear now? Torlak, is it clear for you now? Yeah. So it's very important. You don't give your customer database management system. This is for programmers, so it's advanced. What? Is the answer? What's your answer, Torlak? What do you think for this? What is the relationship that needs to be broken into more two relationship to be able to implement in database management system? One too many, as Brand said. Yeah, and you also told like, yeah, right. What is the surrogate K? Which one? It's a meaningless artificial K. Yeah, exactly. Exactly. It's A. SQL. What is SQL? It's B, database querying language used to process data in database. Okay, so we are done for today. I just ask you to please go through the book, and also if you also find something, please try to search, find in internet. If something is still not clear, you can also write in chat, and then we can also go through that next time. Isn't each, or there will be more classes? No, it's 2.5 hours each exactly. I can give like more times, but I want to give you like more time. I wanted to give you just more time to go through the task, because you have a task and you have to just think how to solve it. So if you want, you can just try to finish it, and I can like support you in chat like later. Like you just go through this the lecture. Do you see the task or not? Like the task which you have to solve, like this transfer task. No, there is a task. I will share with you again. Just a second. I will share with you again now. Stop sharing. Share. Okay, can you see the task now? No, no. Okay, this is the task. As I told you, you have this material, right? You have this presentation. You got this data already. You can access to them. So you need to next time to present your results. I mean, I can give you like time now, and then you can present this. But I just need to give you time, and the next time you can just present this in the lecture, like like the task here to convert the following part of job offer letter into. So from here, dear Mr. Jones, you wanted to like get this job offer letter into a record and in a relationship by extracting the entities and attributes. So you go through all this information inside this one, inside this letter, and try to convert this to a record in a relation by extracting the entities and the attributes from this data. Okay, so please read this in details, and next time you will present this in like how you solve this and so on. Okay, so any questions or anything? Then I see you next time, and if you have any question, you can just write them. The next class it's next Monday. So please try to finish this task as soon as possible, and get it ready. It's the same time, every time at 6 p.m. Every time 6 p.m. Uh, next Monday. Okay. See you next Monday. Bye bye. You too. Yeah, I mean, when I stop recording now, when I stop record, it will directly will be added. Like I will